Bom dia a todos. Bom, vou fazer a abertura em português e depois nós vamos ter a palestra, e a palestra será em inglês. Bom, primeiro eu quero agradecer a presença de todos, não só que estão aqui nesse ambiente, mas também quem está nos vendo aí nos outros campos da universidade. Essa sessão está sendo gravada de modo que ficará disponível aí para qualquer pessoa interessada nessa linha de pesquisa que tem se tornado importantíssimo para o nosso país, sobretudo no momento em que nós estamos observando movimentos intensos no Conselho Nacional de Educação para mudar as diretrizes dos cursos de engenharia do país, né? Esse movimento teve início agora em agosto, de modo que, ao final do ano, provavelmente, nós já teremos algum draft das ideias que serão emanadas do Conselho Nacional de Educação. Muito embora as universidades públicas tenham autonomia, quer dizer, não tem, vamos dizer assim, obrigação de seguir as diretrizes do Conselho Nacional de Educação. No entanto, é conveniente que a gente as entenda e, eventualmente, façamos alguma adaptação dentro aqui do nosso ambiente, né? Como também nos outros campos da universidade. O título do evento é A Nova Ordem na Educação da Engenharia, Desafios e Perspectivas, né? O que nós temos observado aí, através de manifestações, sobretudo de pessoas que vão aqui falar, o professor Bevilacqua, o professor Mário Salerno, a professora Roseli, que está no ambiente, que tem uma profunda ligação com essa questão da educação e engenharia, né? Nós percebemos que a Escola Politécnica, e creio eu também as demais escolas, tem muito a contribuir para uma mudança dessa ordem da engenharia. E para tal, nós começamos aí essa discussão que eu creio, espero eu, que se frutifique e gere novas ideias que possa ajudar aqui o nosso país, né? Que, só a título de informação, em recente evento que eu estive presente lá em Brasília, organizado pela ABENGE, né, o presidente do Conselho Nacional de Educação da área das engenharias, né, o diretor dessa área, relatou que, em 2016, 46,2% foi o índice, a taxa de evasão identificada por aquele organismo nas engenharias em todo o país. Quer dizer, é um número, um índice de evasão muito grande, e dentre as razões que foram sugeridas, apresentadas, que levou a esse índice, né, está justamente a forma como o curso de engenharia é oferecido no país, né? Nossos cursos de engenharia são muito travados, eles são submetidos a regras muito que impedem que as instituições promovam inovações. Inovar num curso de engenharia é muito difícil. Nós, apesar da autonomia que nós temos, né, nós temos inovações importantes na escola, mas são inovações que ficam apenas localizadas, são pontuais, né? Não se proliferam em toda a instituição, até que seria muito bom, porque para se discutir a validade até delas. Mas, no entanto, a gente vê inovações aqui e ali, mas não vemos uma integração dessas ideias. Talvez a gente consiga isso com esse primeiro, né, evento para discutir essa questão. Nós teremos nessa mesa 3 pessoas importantes da engenharia, né? No nosso país, sobretudo o professor Luiz Bevilacqua, que está aqui, que é uma pessoa que eu tenho uma admiração muito grande, que, dentre outras coisas, criou a Universidade Federal do ABC. Foi o primeiro reitor da Universidade Federal do ABC. participou da formatação daquela universidade. E todos conhecem, que estão aqui presentes, a Universidade Federal do ABC, que se tornou, pouco tempo, uma instituição de pesquisa tecnológica importantíssima, na minha opinião, por conta do modelo que foi escolhido para a Federal do ABC, que, a meu ver, deu muito certo, se enquadrou muito bem dentro do perfil da tecnologia do nosso país, né? Então, eu agradeço muito a presença do professor, né, que, de fato, vai nos dar aqui uma visão muito boa das ideias que levaram a conceber esse modelo e, quem sabe, como nós podemos extrapolá-lo para as futuras ações na engenharia, né? Vamos receber também o professor Mário Salerno, um estudioso das engenharias, líder do laboratório, do Observatório de Inovação, que tem uma parte que se preocupa com a engenharia muito importante, que é o Engenharia Data, estou certo, né? Que discute, que faz um acompanhamento online da evolução das engenharias, e, de fato, é uma pessoa que tem uma visibilidade muito grande na educação e engenharia nesse momento, né? E, evidentemente, eu convidei Paul Gilbert, né? Paul Gilbert, que é CEO da Quanser. Quanser é uma empresa que trabalha com equipamentos para laboratórios, diferente, mas ele não é um CEO que está lá só projetando, ele tem uma preocupação muito grande com a educação. Paul has more than 30 years of international business experience. He has led a variety of engineering SMEs for 20. His initial experience was with multinational Schlumberger, worked in both UK and then North America. For the last 15 years, he has led Quanser, world-leading educational and research solution for the global academic community. He is passionate about improving education and research quality. So, I invite Paul Gilbert and also Professor Luiz Bevilacqua and also Professor Mário Salerno to take a place on the table. Nós vamos dar início à nossa sessão, convidando Paul Gilbert para a sua apresentação, e, na sequência, o professor Bevilacqua e o professor Salerno contribuirão para o enriquecimento dessa discussão. So, I invite you.
And thank you very much for inviting me to speak here. You know, first of all, I want to apologize for two things. Number one, I don't speak any Portuguese, so I'm sorry. But Dr. Cardozo says that's not a problem. And secondly, I realized I got the date wrong on my slide, so it's the 14th today, in case any of you are concerned. So Dr. Cardozo has asked me a number of times to come. We've met in many conferences around the world related to engineering education and had many conversations. And, I'm fortunate and unfortunate, and I travel too much. And the last time we met, he forced me to come. He said, Paul, you have to come. And I think the timing is absolutely right, not just for Brazil, but also for where we are in the world right now in terms of engineering education. So I want to start here. We are in the business, you are in the business of educating professionals. I don't know if you know who Red Adair was. He used to spend his time fixing oil spills. And his argument was a lot of the root causes of those was bad engineering, poor engineering. So the statement here is, you think you're hiring a professional is expensive, wait until you try hiring an amateur. And if you look around the world, there's examples of bad engineering. Not just bad engineering, but bad engineering decisions. The Gulf of Mexico disaster, there's all kinds of things that could be pointed to. I also think that there's a lot of great engineering happening. And we're on the cusp of some really amazing things around the world, but there's challenges, as you know. But I wanted to make this point because I think it's very important because of where I travel around the world, and I'm fortunate that I spend, I would say, 40 to 50% of my time internationally with universities around the world. The vast majority of them are struggling with ways to get students motivated. There's retention issues, which I believe is a problem here in Brazil as well. The motivation issues, and a lot of it stems from the youth coming through at the age of 18, and they come into a university system which has the same kind of education process which has existed for a number of years. So what I'm going to do today is I'm going to just provide some observations that I have and talk about some of the work that we're doing with many universities, and hopefully we can have a bit of a discussion after that. So, of course, in engineering, there's the fundamentals, roads, waters, transportation. Those are really, really important issues which require not just maintenance, but improvements. And the innovators. And the innovators are now looking into, other areas of healthcare, sustainable energy, artificial intelligence, unmanned vehicles, and so on. I always put another comment up here too. Leadership. One of the things that scares me the most when I look at governments around the world, there's very few technical people sitting in governments, whether it be the United States Congress or the British government or the Canadian government. Not enough engineers are encouraged or motivated to go in this direction. And I think that's something that we should be encouraging our engineers to do, because policy on an engineering side is really important. So why do I care? My company is called Quanser. Quanser comes from two words, question and answer. We've been in business for 28 years now, and what I like to just highlight here is, by the way, I'm not about to go through all of our products. That would take too long, and I don't think it's the appropriate thing. I really wanted to highlight the fact that we focus on research, advanced research in controls, robotics, and mechatronics, and now we're expanding in some other areas like sustainable energy and electronics. And we take a lot of the learnings that we have there to provide platforms for research, but also bring it into educational platforms which are affordable and, another keyword, flexible. Because we understand around the world that engineering equipment budgets are very, very important. We're in a golden age of engineering. I mean, really, if you look at what's happening right now, pretty much everybody on the planet is carrying a smartphone. I think sustainable energy or environmental awareness is peaking everywhere in the world, except for maybe in some parts of Washington. We have biomedical unmanned vehicles, which are going to make a change all over the world. And there's lots of prospects for improved transportation safety when you think about those kind of things. I spent a lot of time recently in Nigeria and Ethiopia. And, there's a lot of work to be done there on the basics, fundamentals, infrastructure, and water. The technology is there, but is the engineering will and desire and capability there? So from my vantage point, and when I travel, I think we're in a bit of a perfect storm right now in terms of making a change around the world. And as Dr. Cardoza said, I've been with Quanser for about 15 years. And I can tell you that the difference between 15 years ago, 10 years ago, and today is simply this. There's not talk anymore. There's things happening. There's some very exciting things happening. It's very easy for people like myself or other people from industry to criticize. It's very, very hard to change the educational system. But now we've got a number of forces. So we have a global shortage of engineers on the horizon. If you follow, I can't remember the name of the author, but there's a very interesting author that talks about, you can understand the world if you understand demographics. And right now, we're seeing a lot of people around the world retiring, moving out of the workforce, and there's not enough people coming into the workforce to be engineers. So if you're in Nigeria, for example, they're concerned now that all of the engineers that are supporting them with water, sanitation, infrastructure are going to be sucked out of Africa, and they'll have no one to help them. So they're frantically building capacity, and that's happening in many countries around the world. Nigeria, Ethiopia, India, the Middle East. The Middle East is another place where, historically there's been lots of engineers going over there getting high salaries, but because of the shortage of engineering on the horizon, they're concerned they're going to be coming back to the West, whether it be the States or Europe. you've got a generation of students coming into education who are different than I am, and probably many of you. I have 3 daughters, and they're wonderful, wonderful young adults, but they have a completely different perspective on the world. When somebody put up an equation when I was studying engineering, I wrote it down and I tried to understand it. These millennials keep asking that really awkward question, why? Why should I care about differential equations and Bode plots and so on? What's in it for me? You've also got younger administration, so there's also people now all over the world taking positions of influence, who are in their 40s, mid-40s, maybe late 30s, who grew up with technology, and they're not satisfied with the status quo. And they actually relate more to the millennials than people like myself, who are in my 50s. So that's a kind of a human dimension of what's happening around the world. On the technological side, and there is a lot more happening than this, but a couple of things which I think are really, really critical. The notion of Industry 4.0, smart manufacturing, intelligent devices embedded in a network to enable so many improvements to manufacturing, product life cycle, and so on. That's a wave hitting the world. And the concern that exists around the world is, how do you develop students to graduate from engineering and go into the workplace and become effective as engineers in today's world? It's not an easy problem to solve, because it's a multidisciplinary, interdisciplinary problem that involves more than just engineering, because I think there's a lot of societal issues involved in that. And the last piece there is the mobile platform. The mobile platform has been around a number of years now. Every single student on the planet has at least one, if not 2. But I don't think the education community is taking advantage of them. And there's a lot more that can be done. And I'll talk a little bit about some of the work that we're doing on the mobile platform side. I've entitled this Industry Needs. I was thinking I was going to change it, because it's not really industry, it's societal needs. We need employable professionals. And around the world, I run a small business. I used to work for a multinational corporation, Schlumberger, and then there's the entrepreneurs. So there's 3, simply put, types of companies out there. In this day and age, you can't afford to retrain people when they come out of engineering. And that's probably one of the biggest concerns that exists. The tension that exists is, if you just teach students today's technology, like a certain software platform or a certain ASIC or programming a certain type of microchip, that's not solving the long-term problem. That's addressing today's needs. You need to find a way to have students that can come out and be effective, understand all the various parameters of today's world, but also be capable of long-term learning, lifelong learning. So the tension between the universities and the industry is there. It's a healthy tension, I think, in many places. But really the goal should be, students when they graduate should be able to start the ground running. I hire most of my engineers from a school called the University of Waterloo in Canada. Some of you may be familiar with it. They have 4 work terms built into their program. It's a 5-year program, and every student that graduates has at least, I think, 16 months of industry kind of experience when they graduate. So when they graduate and come to my company, they're ready to work. I'm not advocating that as the model for everybody, but certainly there is something there. So as I thought about presenting this email came across my desk on my computer. It was an invitation from UCL in London, and I've seen a number of these. The question being, our discipline's dead. When we talk about engineering silos, mechanical is different from electrical, is different from civil. By the way, if you want to know, I'm a mechanical engineer. But the reality is, in the world we live in today, I'll put both pieces up here. If you look at the major programs, I think about 70% in the US. It's probably similar in most universities. Talking here, I think the majority of your students at this university, mechanical, civil, electrical. But do they address the kind of jobs, the needs which are being developed? And I'm sure you've heard the statement that most of the jobs that will exist in 15 years don't exist now, or 60% of them, or something like that. So how do you take this traditional model and provide students who are able to do that, like when they graduate? And like I said, it's not an easy task, and certainly I'm not here to criticize, because I having worked in this industry, I realize just how challenging it is. So part of the, answer, if you like, has been bandied around for a number of years. Flipped classroom, interdisciplinary design, blended learning. There's a lot of words. I'm not sure everybody that throws the words out actually understands what they mean and how hard it is to make it happen. And certainly in there are kind of nuggets of real value. And so the idea of throwing these at a university and saying, okay, make it happen, is something which I find really challenging, because that's what industry has typically been doing. Just kind of, hey, we need this, and these are the things you should, look, this is the way to do it. But there are challenges. If you look at the academic community itself, you've got course content, the challenges around curriculum modernization. How do you throw a whole bunch of new things? What do you take out of the course? What should you take out of the course? How do you develop multi-layered learning experiences which are valuable for the students? Accreditation is really important. You can't jeopardize your accreditation standing. Ranking is important. You still need to be able to produce quality students. Faculty and student recruitment, pedagogy, all these things are things that have to be thought through and worked upon. And in any organization, changing technology, the availability of time, everyone's bandwidth, and the amount of money that you can spend on these things, that's always a problem. So, in a nutshell, after 15 years of working with universities, listening to a lot of the comments that have been made, it's hard. But what I'm excited about now is the kinds of things that we're seeing around the world where things are happening and they are changing because of the things that I've told you, the kind of perfect storm. So what have we been doing as a company? This is an example. We work in the field of controls, robotics, and mechatronics. We have a lot of equipment, and for many years I used to get frustrated by going to see equipment that we'd sold sitting on the shelf gathering dust. Used 2 hours a month or 2 hours a week. It's fine. We got the revenue, but that didn't really matter to me. I really wanted it to be used. So in the last 4 or 5 years, we've been developing this kind of thing, like workshops where we invite professors. This was a workshop in New York last year. 70 professors from 50 schools came just to talk about the best practices in teaching mechatronics in this day and age. And it wasn't about us presenting our equipment. It was about them having the opportunity to talk, and now we're facilitating this community. As a result of this, we've been able to do the same thing in Denmark. I was at one in University of Sharjah in Dubai. We're doing one in a few months in Malaysia. And then next year we're doing some in China. I'm hoping maybe we can do one here in Brazil. And we've got some organized for Nigeria. The purpose of this is to take the ideas and then see how do they fit within your organization. I mean, USP is very different from, let's say, a university called Afe Babalola in Nigeria or the University of British Columbia in Canada. It's not a one-size-fits-all problem. And we've been developing kind of our approach to different types of universities, and one of them is really true collaboration, and that's what this starts to do. And then I recently read a paper that was delivered by MIT, and I would highly recommend it, actually. It's kind of an interesting paper. And they came to the same kind of conclusion that we had, and that is this. You've got the designer universities. I'm not sure if you're familiar with some of them, but there's a few around the world, 3 or 4, where they've been given the funding to create a brand new university. Olin College is one of them. There's a new one in the UK about to start, which I'll talk a little bit about. Well, they have a brand new, new lease of life. They can do whatever they want. But there's only a handful of them. Very exciting stuff happening there. Then there's the transforming universities. Those are the universities who've taken the decision, and it's a very bold one, to completely change their whole system from top to bottom. Every single department change curriculum across the board. That's scary and very, very hard. I would argue that the bulk of the need we call it the willing majority. These are universities where everybody knows there has to be some change. You want to make some change. It's expensive, time-consuming. How do you do it? And it's like the problem is so big. How do you make a start? And so the goal for us is how can we support a lot of those universities in that space start to make changes in certain areas. I'm going to talk a little bit about the work that we're doing. So Enmite is a new university in the UK. They've been given a lot of money to start working there, and it's the first university to be opened in 40 years. And Dr. Kaczynski, we actually work with him in Canada, and his take on this is really, he wants an education that's designed for this generation, not their parents and grandparents. I'm not sure that that's a statement that you would disagree with. So we've now actually started working with them, and before the end of this year, we are going to be implementing our first, fully developed first-year orientation program for a brand new set of students with a new approach. Their whole evaluation process is based on projects. They don't do any exam-related evaluation whatsoever. It's all based on projects, and I think they're planning to have a 46-week year and do a 4-year program in 3 years. So it's quite an ambitious project. Tec de Monterrey, those of you familiar, it's in Mexico. I think they have about 25 or 30 campuses. They took the decision 5 years ago to orchestrate change. So in 2021, they'll be graduating their first students from this new approach. And again, this is project-based. Their whole development process through the years, including their kind of evaluation, is geared towards projects, teamwork, multi-layered kind of learning experiences. And the onus is on the students to go and find the content to support whatever subject or concept they need to be developing their skills at. These are places where we as a company have been able to cut our teeth in terms of really kind of adventurous ideas. But like I said, it's the willing majority that we want to be working with, because I think there's a lot of opportunity there. I mean, you could work at a civil engineering course, or you could work on the first year program, or work on a distance learning objective, or robotics, or Industry 4.0. What I mean by that is we've developed a kind of a methodology where we want to say, how do you enable universities to develop elite engineers, regardless of what the restrictions are? What we're finding is it's encouraging, or it's exciting for universities or key people. And I'm going to use those two separately. So there's universities that want to make a change. Maybe there's a dean, senior administrators that want to make a change, but it's a big university and it's hard. Look for 1 or 2 or 3 really energetic faculty members that want to make a change and are really excited about a priority application theme. And I'll talk about that in a second. What that means is a global theme, which is of interest to the world, because one of the things millennials care about is the world. That's one of the characteristics of millennials. They're more socially aware and socially, socially kind of active. Then using those themes, design some efficient curriculum and labs. Because in a lot of cases, you don't have the freedom to change, 30 hours a week of lectures into 30 hours of labs. That's not necessarily practical. So you want to find a way to shift some of the time, but make it efficient as possible. Validate some of those labs in a few elective courses. And then what we're finding, and I'm going to talk about some examples. What we're finding then is you get a lot of kind of interest from other people, some envy. Students talk about it, and then the word starts to spread. I mean, we've been working with the San Francisco State University as an example, with one professor in civil engineering who's been doing some amazing work, and I'm going to show you a video. Within the space of 12 months, he's now got the electrical and mechanical departments, 2 or 3 people from each of those departments wanting to do the same kind of thing in their area, using the same kind of approach. And this guy's budget was, I think it was less than $100,000. I think it was like 60 or something. And now he's taken his experience, and he's formed a consortium with 3 other universities to make an application to the NSF to expand the work he's doing. And I think he's applying for a $2 million fund. That's in the space of 1 year. And all it took was a very, very motivated, excited, energetic young professor and a third-year civil engineering grad student. That was it. So what do I mean by priority themes? I think you've seen similar charts. I think the grand challenges kind of opened up these ideas, but things like sustainable energy, clean water, healthcare, infrastructure, and so on, These are areas which, and it's funny, we were just talking about it with Orlando, about the importance of, non-engineers to be involved in some of these areas. So these are kind of applications which I think are more interesting. So the idea is you don't throw out the concepts of mechanical or electrical, civil or chemical engineering. You keep them, but you build some kind of efficient process of electives throughout the program which has the potential of taking students into one of these areas, whatever that area might be for the student. And the idea for us is to say, well, how do you create an agile technology platform that allows you to do that? In other words, how can you develop an environment where the technology they're working on in year 1 can be the same technology they're working on in year 4, and throughout the process, you've gone from simple, guided projects, concept development, fundamental skills, and at the back end, you've got them to a point where they're able to do open-ended design. Because another thing that we've noticed is students get to their 4th year capstone project, and generally speaking, their ability to do open-ended design is limited. There's a few students who've done, project work and, some challenges or some of the projects which are outside of the typical stream. But most of them, and I'm talking about the majority of 8,500 universities around the world, I'm not focused on USP because I'm not an expert over here, but a lot of students get to 3rd or 4th year, and open-ended design is a challenge for them. And we're saying, no, let's start that process in year 1, get them motivated, let them understand what the big challenge is. And we're talking about what we like to call transformative labs. Labs which will take students from being worried about why the hell am I learning how to do calculus or differential equations and so on, into, I understand why I'm going to be using this down the road. So you start off with some interesting, fun experiments on industry-grade equipment. This university on the left is University of Sheffield. We've been working with them for, 2 or 3 years. That building was built, designed, and implemented specifically for first-year undergrad students. They have labs in there for all subjects, not just controls and robotics. They've got medical, they've got chemical labs and everything, but they're using state-of-the-art equipment. They've got MRIs in there, and they've got chemical processing facilities in there, which are industry standard for first-year students. And they have a very big lab of our equipment in there as well for first-year students. The point is, they're getting to see the end game, so that when they're doing all the other work, in their studies, they've got a sense of what this is leading towards because they've actually experienced some of it. So obviously, some of the experiments they're doing are relatively simple, but then they can get into kind of guided design more easily, and the motivation factor for the students there is off the dial. The University of York created the Lausanne School of Engineering, brand new building there. They've turned their courses on their heads too. They've got open spaces. We've been working with them to transform a number of their courses, and I'm going to talk about one of those in a few minutes. And the University of Incarnate Word is it's a very small university, 250 engineering students in total, in San Antonio, Texas. But they have the largest unmanned vehicle system we've ever sold to anybody in the whole world. Why? Because they wanted to have that as their priority kind of application, and they've used that, and now they're developing curriculum for first-year, second-year, third-year students using this advanced research equipment. It's fascinating what they're doing. And actually, they've taken it one step further. They've created a girls in engineering and math and science course for the summer. And every summer, I think this year there are like 160 young girls from disadvantaged areas between the age of 12 and 16 came and played with this kind of equipment, under the guidance, obviously, of the grad students and the professors. So that's a very exciting development. So these are just 3 examples of, holistic change that's being made within a university, not trying to change everything, but trying to change kind of pieces of the puzzle. In our world, the robotic area, these are some of the areas which we tend to work in more closely: space and defense, autonomous, biomedical, smart industry, and also a little bit of work in universities in California in the entertainment industry. representative kind of products that we use, but it's not so much about the products, about the application and the understanding of the technology behind them. If you look at our slightly adjusted chart there, foundational control and mechatronic skills and physical robotic platforms. But what I'm going to show you now is just a few examples. So I mentioned the new model in technical engineering in England, the brand new university. We're proposing that, actually, and it's happening now, is the Modern Engineering Transformational Learning Lab, where they have design experiences. So really early on, they're being given some fundamental platforms and simple, relatively simple design exercises so they can grasp key concepts. Modern industry, we're taking robotic devices, and that flat platform there is a block there that provides a full simulation of industrial or agricultural or other kinds of areas. So we can develop environments of all kinds using the same technology in terms of kind of interface to those environments. Human-machine interface, so QDEX is a mobile platform that we've developed, which I'll talk about later, but everything that they're going to do here, the content is going to ultimately be available on their mobile devices for students to use, which is fully interactive, interactive in the sense that you can have graphs and charts and change variables, you can stream data, you can interact with the devices. That's the level to which they should be getting to. And then applying these techniques to global challenges, and those are just some plants which are representative of different physical concepts, which again can be linked to a simulation. You could have water flow treatment for water purification issues and so on. So that's the one that we're doing in the UK. I mentioned earlier San Francisco State University. This is a video that was made, and I want to show it to you because it wasn't made by us. This was made by the professor. This is the one I told you. One professor, one grad student, and in the space of 12 months, they created what I believe to be probably the best example of a remote lab that I've seen using our technology. But just give me 1 second. Sorry. What is that?
We propose to harness the power of mobile technology and Internet of Things to develop this standalone mobile laboratory. Through this mobile laboratory, students will be able to assess this exciting experiment through their mobile device right on their fingertips, anywhere and anytime.
This is different from a traditional lab because it's a purely remote lab, meaning that students can access all the different components of the laboratory through interactive educational mobile apps. My
experience with old traditional labs, you would actually have to be inside the lab and do the labs. Versus this new lab, you're able to go ahead and be outside in the lawn area in your home or in another classroom, and you're able to perform this lab.
So we used a mobile development framework called QDEX, and so QDEX offers a really fast and easy way to transform conventional static learning materials into interactive educational apps. The three different components of the learning module are analysis, simulation, and experiment. And so analysis represents the theory, simulation represents the practical examples, and then experiment obviously represents the experiment portion. In order to provide users with a real sense of participation, a telepresence robot manufactured by Double Robotics has been adopted and integrated into this remote laboratory.
So the telepresence robot is basically a stand with an attached motorized wheel and iPad. And what it does is it allows the user to be at the location while not physically being there.
Users can control the Double remotely to walk around the lab and view the experiment from different angles. Users can also speak with a lab assistant that is physically in the lab and even modify the configuration in real time. The experiment is conducted through an innovative mobile remote shake table laboratory, which was developed in the Intelligent Structural Hazard Mitigation Laboratory at San Francisco State University.
A lot of the labs I've done before, it's using old technology, whereas now we're using instruments such as our smartphone or our iPads. You use that every day, but you don't know the capability that it has in terms of learning, as well as in terms of how it's implemented in academia.
95% of students found the module easy to use and felt that it was an enjoyable learning experience. 89% of students agreed that it helped them improve their understanding of critical concepts, and 84% of those participants would recommend it to a friend.
I would definitely recommend this lab to other students. It's interactive and it's through a mobile app, so something that we're all familiar with is using our phones.
Our ultimate goal and ambition for this mobile laboratory is to enhance student learning by expanding this mobile laboratory and establish the Mobile Laboratory Consortium to share the expertise and equipment within our engineering community.
So I showed that video in its entirety for the simple reason that we didn't make it. This was a university prof who saw the mobile platform that we developed, and we did a pilot study with 5 universities over the last 18 months. We're actually going to launch it to the Global Engineering Deans Council in Canada in a month to make it generally available. But they took it and they linked it relatively easily to a different software package, the streamed video. They put in that mobile device. And it was the creativity of a young prof and a third-year grad student. And that university is now taking those concepts to the electrical and mechanical department because that professor has a couple of friends, that student has a bunch of friends. So now they've created, I think, a little mini army of guys who can program the mobile apps and start putting these in place. And, you know, I don't know if you know, but this state university system in California has no money right now. So he was able to do that with a very small amount of money, and now is applying for big funding to grow it. And you know, it's a success story which we're very proud of. This is one of the courses that we started from scratch at York University. So it's a measurements course, which I think is pretty fundamental to any engineering degree. Typically taught in Canada anyway in the second year. And they used to use these, you know, monstrous devices on the left. They were very abstract. You know, you have some kind of sensor, you test it, you change the parameters. But it's doesn't really mean much. So we've said, well, why don't we look at the sensors which exist on our equipment? And going back to my point about reusing equipment, those equipments that can be used for teaching controls and robotics. But why not take advantage of the fact they have sensors? And actually start to understand why is the sensor used in a certain way. So, you know, you look at strain gauges, you're looking at, you know, heat sensors, flow control sensors, and then you add some, you know, virtual instrumentation. So this course was developed by Quanser and a professor at this university, and it's a lab-based course. There are small vignettes of lectures. There's some small theory components that they teach. But they bring the students in, and the most of the course is hands-on. And at the end of the course, and this is a second-year course, by the way, at the end of the course, they say to the students, okay, come up with a simple gizmo using sensors. And this is kind of what we're talking about when we talk about, you know, guided design. You provide them with, you know, actuators that work, or you provide them with kind of devices that work, and say, use your sensors to do something interesting with that device. Here's an example of what one of the student groups did. It's a coin sorter.
The purpose of our system is to verify the authenticity of coins, determine their value, and then place them in separate bins. A ferrous vein sensor is used to determine whether the coins are real. The sensor only detects ferrous objects, and all Canadian coins are steel. This allows the system to reject non-ferrous metal and platinum.
I'll just make the point. Oh, sorry, I didn't mean to do that. I wanted to make the point that the device that the little triangles are sitting on is a standard piece of equipment where you can control, you know, the position. They don't have to worry about that piece of the puzzle. All they need to worry about is what the sensing thing, and send a command, and they're done. So my apologies. I just go back to this.
A backlight, in this case a cell phone screen, is placed behind the coin to ensure a consistent and high contrast image of the coin. Once the webcam has taken a photo, it is then converted to grayscale, and the number of black pixels are counted and compared to calibration values in order to determine the size and value of the coin.
Once it has been confirmed that the coin is real and the value has been determined, the motor of the servo unit is turned on and the system rotates until the correct angular position is reached. A potentiometer is used to measure the angular position and was chosen because it provides absolute position sensing, eliminating the need for any initialization when the system is first turned on. The system is programmed so that the dishes rotate in whichever direction avoids the dead spot in the potentiometer.
The programming style used for this system was a state machine. Essentially, the system moves between a set of states that control a case structure. This method has a very logical flow and makes it easy to ensure that the operations happen in the correct order.
So the outcome of this exercise is number one. The students think this is the best course that they've done in their whole 2 years of university to date. Number two, the professor, Dr. Niemer, tells us that the students' understanding of senses is 20-30% better than it was previously. Number three, they've done some guided design. Simple design, project work, teamwork. They had to present, they had to produce something, and they had deadlines. There's some professional skills there, instead of just learning how senses work in an abstract fashion. So when we talk about multi-layered learning, I don't know what the proper engineering term is, because we've made that one up. It's a Quanser kind of term. We're saying in every experience that you provide students, from the first year all the way through to their graduation year, the project should have those multi-layered dimensions. And people say to us, at the conferences all the time, you can't add professional skills into a program because you have to take out too much. Mike, you don't have to take out too much. You can augment what they're learning. And by the way, millennials are multitasking. Well, I've been told by a psychiatrist friend that that's actually physically impossible, but they claim to be, and they seem to be, able to deal with multiple things in a kind of a parallel fashion instead of a linear way. So this is a very exciting approach. So that's a second-year course. So another university, the University of New Mexico, they had a problem with their retention rate in their first year. They had a number of students dropping out. The math was too hard. They didn't understand. So they said, let's focus on a smart planet, the idea of intelligent devices networked everywhere. That's something which all the students can get a handle on. Provide some early stage motivation, relevance, big picture discussions, and do it using real systems, real tools. In other words, real quality systems, not toys. And I don't want to disparage too much the hobby style kind of controlled teaching that's been in place in many places, but it's just that, it's hobby, it's not true engineering. And I go back to my professional statement from before. You're training professionals. So real tools and do real engineering. So we're about to launch, again, I think this is going to be in the spring of the winter term, January of next year. The Y Lab, what do engineers do? Show them some really interesting stuff and give them some insight into how the heck you do those things. And then answer the question, why am I taking this course? Why am I doing these concepts? Why do I learn these? Well, because they begin to understand how they integrate and build up in there. So the whole first-year freshman course is designed for them to come into school and to get to grips with what engineering is all about. The fun side of engineering part of the challenge is I think engineering has this reputation as being boring. It's not. But if they come in for 2 years and spend 2 years in class looking at mathematics or whatever, concepts on a whiteboard, that's going to destroy their motivation. So this is very exciting. Another application that we've kind of talked about, again, I'm talking about reuse. In fact, we were talking a little bit about this last night over dinner. The idea that how do you have an open space where you can have some creative ideas develop? So here's a bunch there's 4 or 5 different products that we have. Each of them can be used independently to teach concepts. There's one there that teaches actuators, so it teaches you the difference between different types of motors. There's a sensors board. There's a communications board that teaches different kinds of communications, which is required for any kind of mechatronic application or any networked intelligent device, and a few others. And we brought in some first-year students from a local university and brainstormed some ideas. And they came out with this idea. Well, why don't we turn that into an industrial load? That could be a solar panel. That could be a residential load. That's a community power source. And let's get some solar energy collection, and let's link them together. Every single one of these devices has a local processor, so it's kind of like an intelligent device in and of itself. You've created a lab cloud. You've now started to introduce principles of Industry 4.0 to a first-year student. And they don't fully understand everything, and it can be taught at a high level, then you can break up and look at the individual components, and then you can start building it up again. And to your point about having an open lab, the idea of having equipment which is flexible enough and intelligent enough, in other words, that each device has some intelligence connected to it, gives you the ability to do a number of things. Team projects, simple design to complex design, and multi-layered kind of learning, including those professional skills. At the other end of the spectrum, we're working with a university in Dubai who want to build their research capacity in mechatronics. They're really keen to develop their ability to do intelligent machine design. So we provided a number of our platforms, the software platform and the intelligent kind of networking capability. And one of the key components here is over on the right there, is the boot camp. We're basically providing them with, I think it's a 3-week, it could be a 4-week course, we're not quite sure yet, but 3 to 4 week course where a student that's graduated that doesn't have research skills, that doesn't have a lot of skills they need to do research, is put through their paces in terms of all the basic skills you need to be able to work in a lab. And our experience is a lot of students going into grad labs, having graduated, spend at least 6 months, if not longer, developing those skills to do research. So that's kind of a new concept we're excited about. Another university, this one's in Nigeria, completely different set of issues that they have. They have basic infrastructure issues. They have basic energy needs. They have water problems, sanitation problems. So we're working with them, and I'm very proud I can pronounce that, the Obafemi Awolowo University in Nigeria. It's actually similar in some ways to USP. It's the largest state university in the country. And they want to do a complete overhaul of everything they have there. And we are working with them to develop regionally relevant challenges for their students from the first year onwards, and providing modern and rigorous capability for each of their areas. Their students, when they come into university, are not as prepared as students in probably here in Brazil or in the US and in Western Europe. So they have a lot of kind of development work they have to do, but we're working on ways in which they can speed that process up. QDEX. This I'm just not going to talk very long about this, but it's something I'm extremely proud of. We've spent the last 4 years working with the academic community to develop a mobile platform that allows someone with very limited programming knowledge to create mobile apps. And why is this such a big deal? Because everyone says, well, mobile apps exist all the time, right? They're everywhere, ubiquitous. But if you were to ask a thermodynamics professor or a circuits professor to take their course notes and everything and create 12, 15 little modular apps, fully interactive with their tech, could you do that? The answer is no. You'd need a computer science degree, and you'd probably need a year's worth of time to program it and everything else because the existing platforms just weren't there. So we took a look at what was happening and the fact that the mobile platform wasn't being used properly. We created this. You can create an app in less than a day that runs on an iPhone, an Android platform, tablet, phone size. Some key features. Every app has to be clean and crisp, because students today, if they don't like an app, if it doesn't work within 20 seconds, they're not going to look at it. It has to look and feel native. We're using the power of the processor. This isn't done in HTML. It's not a web-based design. This is an app designed for the Apple and the Android environment. And as I said, we've been doing pilots with 5 universities around the States and Latin America as well. And we're going to launch this. And I can tell you that within about 3 or 4 days, a third-year student or a grad student can get up to speed in terms of their ability to program in this language. And in University of New Mexico, for example, I think they now have 15 students. It's become part of 3 or 4 of their courses now. And the rapid iteration of these modules allows them to kind of perfect it as they go along. But We're saying this is a bit of a game changer for the academic world because we've come from it from an academic perspective. Half of my staff have, not half, sorry, half of my engineering team have done TA work at universities. 3 people in my management team have adjunct professor positions. So they spend time working with universities on curriculum development, and they sit around talking with faculty on how to improve and introduce modern techniques. So this is something which is, like I said, it's going to be launched officially next month, but it's something which allows you to tie together any kind of equipment. This isn't tied to Quanser equipment. This is an open platform. So if you can stream data, you'll be able to stream to this device. Sorry, this platform. Final slide, and thank you for your attention. I really appreciate it. We did a survey of customers around the world, and I can't remember how many, but it was a pretty large survey. The one thing that came back that we were really proud of is this notion that we are viewed as colleagues and not vendors. Sure, we sell equipment. That's how we make our living. That's how we hire the best engineers. It's how we develop technology which is geared towards teaching and research. But I can tell you, from our vantage point, our mission is to improve engineering education. Nothing gives my engineers or my guys a bigger kick than to see a 22-year-old or 21-year-old student developing something like that coin sorter. I mean, they get it, and they're getting it quicker, and they're having fun doing it. And bringing grade 11, grade 12 students, your 17-year-old students coming into our building, providing them the tools to write a mobile app that can control that device over there. Grade 11, grade 12. You can do it in the first and second year. So hopefully you've got a sense of what we think is driving the world of engineering education. It's a really, really exciting time around the world. So much is happening, and I think the days of the criticism of the academic institutions should be gone, because I think the desire is there. But the challenge is monumental to change everything. And in an institution where it's just impossible to change everything, find a way to change something small, but then shout from the rooftops about it and share it with as many people as possible. And the technology is there to make it happen. Thank you very much, and I'll end it there.
Antes de fazer os comentários, eu queria deixar alguns avisos, que nós estamos ao vivo, né? E o site para acessar é www.iea.usp.br/ao vivo, tudo junto, né? E também está sendo gravado e vai ficar disponível a todos, né? E quando tiver perguntas, por favor, se identifiquem no microfone para que seja registrado. E perguntas podem ser enviadas para iearesponde@usp.br, tá? Sem problema. Os vídeos e as fotos estarão disponíveis na mediateca do IEA dentro de 15 dias corridos. É no www.iea.usp.br/mediateca. Bom, eu queria agradecer, então, I would like to thank you for your speech. Agradecer o Paul pela a sua palestra, né? E convidar o professor Luiz Bevilacqua para as suas colocações sobre o evento. Creio que you can take space.
Stay here. Okay. Okay. Okay.
Okay.
Well, thank you very much for this invitation, Professor Cardoso. Very, very nice presentation.
Thank you very much.
I think we have heard very interesting experience from other universities in your outreach in several countries and all over the world. I'd like to make some comments. Well, first of all, I think your presentation has shown several experiences in different universities in different parts of the world. One thing that if you can explore a little bit more with more details is about the culture. I mean, at the very end, I have some questions or comments, and then because culture, it's very important, I think, in the education system. For instance, if you think of this country that has very, very nice also universities, very, very well successful universities, there is a point that I think it's difficult to find around the world. When a student applies for a Brazilian university, he chooses his own topic, engineering or physics, and even engineering, civil engineering, mechanical engineering, from the very beginning. They are not allowed to enter the university. I think almost all universities, except one I will mention in a little bit later. So I think this is also a difficulty when you are talking about education and also engineering education. Second point is how they face new challenges, you see. I think that we need in this country also to stimulate the students to face new problems with courage. You see, they don't have to be afraid of taking risks. I think this is one point in our education that I would like you also to make some comments, okay? Well, now, about your some points of your presentation. You mentioned storm, right? We are living in storm. I have also in several talks mentioned, not with this name storm, but cultural shock, technological and cultural shock. And the image is the following: a shock is a shock wave is a non-linear phenomenon. So a non-linear phenomenon has not a unique solution. And what I'm trying to explore and to talk to people in several places, mainly in Brazil, is that it's impossible to find one solution for engineering education. We are living a non-linear problem. So several different solutions are possible. So this is a point. And if we are living a non-linear problem, a shock wave, and if you compare shock wave with ocean wave, we cannot swim in the ocean wave. We have to surf. What is the meaning of this? The very old technologies, the very old approaches are not valid anymore. Now, what are the solutions? And you mentioned, I think, very properly, very large universities are very difficult to change. And then we have to start with small things. I see in this university small initiatives like City. Where is Rosalie? Rosalie is there. Yeah. She's doing an excellent job here, you see, promoting new ideas, open this, the lab for innovative solutions and challenge problems. So I think this is possible to be done in a big university. But Paul, we have had the opportunity to start a new university in Brazil. And you mentioned also that, for instance, what is a differential equation good for? Why do I need this? What are, you know, I took my graduate courses, I finished my graduate course in 1959. I am old. And I had physics 1, 2, 3, 4, calculus 1, 2, 3, 4, and chemistry 1, 2, 3, 4, and so on. These are 50 or 60 years ago. Nowadays, what we have? Physics 1, 2, 3, 4, calculus 1, 2, 3, 4. It's impossible that the same thing are still going on after 50 or 60 years. So And this, based on these ideas, we, and this I'd like you also to comment if you think so. It would be interesting. We have started a new university 11 years ago here in this state, UFABC. And our thinking of all these points that I mentioned, and you mentioned also, we don't have physics, chemistry, calculus. It's quite different. The basic topics are energy, structure of matter, communication and information. Instead of calculus, we mentioned representation and simulation, which means modeling, mathematical and computational modeling. So they are introducing the math with something interesting to explore, right? And transformation process. Transformation process is engineering. Transformation process could be mechanical, civil, these new areas of medical engineering and bioengineering, you see. We have also stimulated very much cognition and neurosciences together with engineering, which is a very, very new field and is blooming. It's fantastic. And finally, we have also a group of discipline in humanities and social science, because engineers are also living in a civilization, right? They are citizens. So now, what is missing? Well, first of all, to prepare a course on energy, we have to get together physicists, chemists, engineers, biologists, to say what is the fundamental that a student in a university has to learn in the modern world in this field of energy. Then they can explore their some specialties. They can follow other courses more focusing in some specific points, but the basics is there. Also, structure of matter, again, communication and information and so on. And if you, for instance, see what is the main topics of a new project, it's called here in Brazil, Serra Pilheira. I don't know if you're aware of this. It would be interesting. It's a fund, and private fund, about $100 million or something like that, for some years. And what are the topics they are asking to be explored? I mean, the candidates, they have to present some research in which topics? Energy, matter, communication and information. You know, everything is looking at these new areas, because these are areas where people, they have to concentrate their knowledge and their effort in engineering and other fields. At the University of ABC, for instance, the students, they enter the university, they don't have previous choice. They have only about 40–50% of disciplines that they have to follow. They are mandatory, but the other 50% for the first stage, they are free. So this is another point that people talk very much about entrepreneurship, right? And what I think that in this country, we try to explore this activity with courses. But the student in this very wonderful period of life, when they are young, they don't have the opportunity to exercise entrepreneurship, choosing their own way in the university. They are forced to follow a track that is prepared by the authorities, by the engineering groups and committees and so on. And this has to be also modified as far as I think. So these are very brief comments. I think that this university, in UFABC about, well, Professor Kaminsky is a professor there. It's about 50% of the professors, and now I'm going to talk to people, you people here at USP, 50% of our professors were graduate where? At USP. And you don't take advantage of this thing. You should say, well, your university is, for instance, in the higher, Times Higher Education, right? The recent ranking. In Brazil is the fourth one with 10 years of activity. It's USP, Unicamp, Unifesp, and UFABC. So, and people in USP, they ignore this. You don't follow your alumni. And you don't say to Kaminsky, well, we are so good because of us. Why not? Why not? So I think this is to say that we lack the culture, a country's culture is also very important in all this establishment of new ways and new roads for the university. Just to finish, because I think the discussion could be better, thank you very much for your presentation. I think this, mainly your last slide, you see, you are not trying to be a pure commerce industry. And I think this cooperation between the universities and your institution, I think it's very, very interesting, and I think it could bring, I mean, for both sides, yeah, very interesting projects, because I think that probably you could find in some universities what they need, where they are trying to develop some new ideas and so on, and take advantage of this. So I agree with you that engineering education, not only engineering education in general, is under a very, very strong modification all over the world. And we have to be preferably, I think, cooperating instead of competition in education, because this would be very bad for our world. Thank you very much.
Okay, thanks. Professor. So thank you so much, Professor Bevilacqua. And now I call him Professor Mario Salerno. This is the
good morning. Thank you for the very nice and interesting presentation. I was thinking of which could be my contribution. So I will first present myself, and then I'll make a very brief thought on the engineering problem nowadays in Brazil. And then I'm going through an experience we have had in our department, production engineering department, in the, I don't remember exactly, in the 80s or 90s, more or less, with Waterloo. Okay, but well, let's go. Well, I run in university the Observatory of Innovation and Competitiveness, and with a kind of system we call engineering data. It's a there is the reunion, the meeting of the collection of public data on engineering altogether, employment, wages, education, formation, engineering service companies, publications, to say. And we made some analysis based on this data, okay? Well, it's all public, you can say. First interesting thing, when the economy was booming, the access of this site was mainly by Americans, not by Brazilians. Was American companies interested in investing in Brazil So they are trying to figure out the engineering panorama, formation, and so, and go to the site. It's completely crazy, but it's real. We made an analysis because in 2008, 7, 8, there is a discussion, the same you pointed out, on the lack of engineers in Brazil. Because the economy was booming, there is a discourse on innovation, and so on, and so there was a discussion on the lack of engineers in Brazil, especially civil engineers, because construction was booming, infrastructure was booming, and so on. Okay, we made a lot of analysis, and so it's kind of strange because there is not a formal lack. What was the issue? So we went to talk to some companies. They are claiming against project leaders. Okay, to say experienced engineers able to run and manage complex projects. Okay, for an infrastructure system or whatever, and. We went to the census to see what was happening, what happened to the formation. And in the 80s, what we call the lost decade, there was a fall in the formation of engineers. Now, our hypothesis is that these engineers that should be graduated in the 80s would be the team leaders now in 2008, and there was not. Maybe the problem is that maybe we are living the same problem, okay? Because now economy is down, the appeal of engineering courses is relatively down, so there is a real problem that in 10 years there will be a lack of project leaders and so on. Okay. I deal with organizational theory, okay? This is my field. In organizational theory, there is a statement. You have a choice. Whether you can design an organization with a complex organization with simple jobs, or you can design a simple organization with complex jobs, okay? Maybe this is the difference between the design of UFABC and the University of São Paulo. When we try to do something new, there is a new department. I think it's crazy in the electrical and civil engineering to have a course with 4 or 5 departments. I can't understand how it runs. You know, there is a civil engineering course, 4 or 5 departments, I don't know. There is an electrical engineering course, 4 or 5 departments. It's completely crazy. The cost of management in between the departments are so high that you can't do anything. It's crazy, but anyway. No? But I think this is a problem we face. No? And this, I think there is a correlation with this problem and the implementation gap that we have. We have a lot of good ideas, but to implement, it's quite difficult. And now I'm going to the Waterloo, our experience with Waterloo. I don't remember exactly, but Fadigas, I don't know if the old guys remember Fadigas. Fadigas went to Canada. Fadigas was a professor of statistics of our department, was one of the founders of the department. Okay. Fadigas went to Canada. I don't know exactly the history. And he created a kind of team, and they designed 3 new courses in a new campus in Cubatão, a new campus of Polytechnic School in Cubatão. Production engineer, we are involved, electrical engineer, computation, I think, and chemical engineering. I think that's okay. The model he imported was a little bit crazy because it was 3 months at school, full time, 3 months at a company. Okay. What is the problem? It starts in the first year. So the guy, the boy or the girl, entered the university, 3 years of calculus, physics, and so on, and then went to a company. Nobody in the without. We have not prepared the company, discussed the program with the company, what the guy would do with the company. So I was assigned to accompany these guys. Well, they're doing administrative jobs, okay, going to the mail, typing, these kinds of things, completely crazy, nothing to do with engineering. And by the other hand, in the end of the course, in the last year, there was the lack of a more comprehensive integration with the companies, because the model was until the last year, 3 months. And there is no, the default was, the guy went to a company in 3 months and then returned to another company. There was no continuity, okay? But without planning, because they are offering a kind of job, so, and it didn't work. So we went back, to say production engineering. Production engineering has a model a little bit different from the others courses here in the school, because from the beginning we designed the course to have the minimum of disciplines, the legal minimum. There was a legal minimum, to have space in the last year for the guys to go to a company to perform a professional job in the company, supervised by the school. Okay. For instance, my graduation thesis is much better than a master thesis. Okay. The impact is much higher. Whatever you can use as indicator. Anyway, so we went back to this model, and we have in the last year back to this. We have more hours now of relationship with companies, but more more planned. What we want. The companies know what we want. So there is a kind of exchange. It works. So I think it's working. It's working in that sense. So based on this experience and based on some experience we are running inside the structure of the on what they used to say problem-based learning or something like that. For instance, there are some courses I run on of innovation management, and I enter in contact with some companies, 15 more or less. I discuss a problem, and the students go to the company to work on this problem. Yep. Okay, but there is one problem. The structure, they have several courses in parallel, innovation management, thermodynamics, I don't know, a lot of, so they have to manage this. Okay, my question is, I think there is two options, and I would like to hear your opinion on these options, whether in courses like that you should, or more conventional problem-based learning courses. Maybe you have the possibility to have a short course for, I don't know, 15 days, but full-time. So you went to the lab, it's the only course you have, full day, you have to solve a problem, you have, I don't know, 15 days, 1 month, in the end you have to deliver. Okay, you can have intermediate deliveries, but in the end you have to deliver, I don't know, something like that. Or you can have a class 1 or 2 days, 2 times a week during a semester, and with some deliveries in the middle. Which do you think is the best? I think for some courses a concentrated one is best. I'm thinking of, but for us it's quite impossible to do, because students concentrate on the problem, they go to the lab, and they go to the theory, either go to the restaurant, I don't know, they go everywhere to try to solve instead of, I would like to hear your opinion or your experience on that. And the second question is the relationship lab experience and theory. Because there is some discussions here in Brazil that you should abandon theory. I think it's a mistake to abandon theory. Because in the end of the day, you have to know what you're doing. But the question is how the students can learn theory. That's the point, not the theory in itself, because the theory is the knowledge of the humanity along. And I would like to know better how in this course, the course you know and the experience you know, how experience and theory are mixed. How from experience you go to theory, how from the theory you go to the experience to have a better formation. That's it.
Wow. Now I'm going to change my notes. Okay. All right. Thank you very much for your comments. I really now feel like I've got some homework to do, and I'll come back in a couple of months and give you the answer to all those questions. But off the top of my head, I've tried to take some notes. So you started off with the notion of culture and students choosing their discipline at the beginning and not being able to make a change. I've long believed that a 17 or 18-year-old student leaving high school, they're not in a position to really decide what they want to do. They don't know enough. They don't know what they don't know. So I would argue that certainly in a program, I think here you have a 2-year common engineering program at USP. Culturally, I don't know if it's acceptable, but I certainly think from an engineering standpoint, it's advisable to do that. Another thing that's happening in a number of places that we're seeing in terms of introduction of people into school, and this is a movement which I think is really powerful, and I'm not sure whether you guys are aware of it. They're trying to get students who have not done well in math or physics or chemistry into the engineering intake stream, because they're losing a lot of girls, women, and they're losing a lot of very creative people. I remember when I graduated, I always thought I was a terrible engineer. It turns out I'm not a terrible engineer, because I'm not the kind of guy that wants to sit there every day testing something, taking my notes and working. In some people like that. I'm more of a people person, and I ended up doing business, and now I run an engineering company, so I use those skills. And I think the streaming of deciding for engineering, you have to have a high level of math, high level of physics. You're losing a lot of really potentially phenomenal engineers. So what's happening now in some of these schools is they're bringing in students that have shown an interest in the creativity, and they offer them remedial math and physics, enough to get them to a point. They're never going to be the best theoretical engineer, but they don't have to. They shouldn't have to, right? So that's kind of a comment on the culture. I think that should change. Or you mentioned the next one is the notion of risk. I mean, this is probably one of the single biggest problems in universities all over the world, is the notion that failure is bad. No, it's a learning opportunity. I mean, I've got scars all over my body. I have failed so many times. But I learned from every single time I failed, right? I mean, and you move on. My daughters do musical theater, and they just started. They're in their first year program. Actually, they're twins, and they're in their first year program, a musical theater school. And I was joking with them. I was saying, if you were doing an engineering program, the equivalent engineering program, you'd be doing dance theory, singing theory, acting theory. Can you imagine? And then in your third year, then you go on stage and try and perform. Of course not. They have to learn how to control their voice and how to do the dance steps. And if they're doing some crazy dance, leap, they're going to fail. They have to. You can't do it first time. You have to practice and get there. It's the same with engineering. So I would agree with you 100%. And I think one of the things that we're trying to, in the courses where we are collaborating on development, the notion of failure is encouraged. But we don't call it failure. It's a learning moment, right? Oh, that hypothesis didn't work. Why didn't it work? Let's try and figure out a way. And actually, one of the experiments we're working on with the mobile platform is this triaging of understanding knowledge. So to segue a little bit to your point about abandoning theory, no, you should never abandon theory completely. There may be theoretical derivations of, I think you mentioned it last night, how does a transformer work? Do all the students really need to know kind of the in-depth derivation of the transfer function for a transformer and be able to recite it, in their sleep? I don't think so.
Absolutely not.
So maybe there is some theory which is being taught at a more intense level than it needs to be. And I use the old slide rule analogy. There's probably a few people I can see here that may have at high school used a slide rule, and then the calculator came out. And everyone said, well, that's cheating. Use the slide rule. Who uses the slide rule today? So if you understand the fundamentals of a mathematical kind of concept or a technical concept, if you get it, then you don't have to beat it to death. Use it and understand it, and then start using the application of it in a more practical manner. So I would agree. Don't abandon theory. I've got friends who say, you can simulate everything in engineering right now. You don't need to build anything. It can all be done in software. I challenge anybody to get onto an aeroplane that has never been tested physically. I wouldn't do it. I wouldn't get into a car either. I mean, yes, you test subsystems and but when you put it together, you got to test the physical system. And we're doing a lot of work. Are you familiar with the company Dassault? Dassault, they do have a Cartier software. So we're working with them to develop a curriculum for digital twinning. So the idea is, here's one of our products in real life. Here's the product, fully digitized. Every aspect of it digitized. And their software is amazing. And by the way, they're not paying me to say that. It really is fantastic software. But when you get those two things and you operate them, then what are the differences? You begin to learn the difference between the physical and the simulated world. And that is a powerful kind of approach for students, which I think is more valuable than learning every kind of piece of theory that exists. The perfect storm is a beautiful engineering description of it, the non-linearities of the perfect storm and the culture shock. And I think you hit my point very well. There is no one solution. And again, segueing to yourself, the model at Waterloo works. They've been at it for 50 years. They have an army of people that talk to companies, that talk about every single student's 4-month stint. They're not engineers doing that. They're administrators, or they have a team. So if you try and kind of dump that onto an engineering professor, I would agree. It's a waste of their time. And if you don't have the resources or the culture to build that, it's not going to work. I don't know how many students they place every year, but it's a really successful program. And more than 50% of my engineers come from Waterloo. But the same thing has been said pretty much everywhere in the world. To try and replicate that in other places requires monumental commitment and resource allocation. So we've also had the experience of the 12-month student. That's good also. It's a different way of skinning that kind of industrial experience cat, right? So a hat, sorry, which has been fun. That being said, what you're really kind of alluding to is, I think both of you commented on, is the bringing in of real problems into the world of students, whether you're actually physically at a company or you bring in a project. I do think that's something that needs to be worked on by universities. And I think, and this is just my observation, is that it seems to be that everybody's looking for some crazy out there problem to solve. There's a lot of very simple problems that can be solved. And if you're giving problems to first or second year students, they should be simple. And so I think part of the kind of learning that we're realizing is, if you're talking to somebody about developing a first year course versus a third year or even a graduate course, those levels are really important. So if you've got and I saw this in a meeting with, I think it was people from Boeing, Lockheed Martin, Airbus, big companies. And they're coming up with problem statements. You know, a problem statement is like, well, how can you reduce the fuel consumption of a Boeing 747, you know? What first-year student's got a chance of delivering on that promise, right? And there's similar kind of comments around the room. And when they got to me, I think they thought I was a bit of a maverick, because I said, well, you know, maybe you could do something simple like you know, measure the air quality in a plane. That's something that customers would like, isn't it? You know, simple things, right? And anyway, that's my take on that real thing. New university relevance. Yes, that's good. I'm sorry, I'm trying to cover as many of your points because they're all quite good. You asked, this is an interesting comment. Short courses which are full-time versus trying to weave them into some other area. I would agree with you. Some are better suited to that than others. How you fit it into your curriculum, I don't know. One of the things that we are doing, and to be honest, is to understand that a bit better. So we're working with a few international, I'm not going to call them gurus, but well-respected people who do course development to help work with universities to train faculty on modern course development, right? There are some subjects which, you know, if you can't focus on them day and you lose the momentum, I think is the right term. Yeah, you put it down, you come back to 3 days later, you got to kind of go back a couple of days before you can start again. A lot of the newer schools, just for your information, the new schools in England and the other new ones that we're talking about, they pretty much focus on project by project. And their approach is, here's a project, you know, simpler, obviously, in early years, more complex in later years. Their ultimate goal is to mix up, you know, third-year students with first-year students, so you have that kind of managerial style relationship. But they're essentially saying, here's a problem. There's the problem statement. 3 weeks, go away and do it. And you will probably need to learn these subjects to enable you to do that. And now you have to go off and find that content. Or create that content, and so they're encouraging students to create content, and so, you know, there's YouTube, there's lectures, you know, there's lots of lectures available. They have guest lectures and so on, but the onus is on the student to go out and learn that, and then when they get together to discuss, you know, challenging moments in the project development, the interaction is much more meaningful. And I think you actually commented on it the other night. You know, if you're lecturing to a group of 60 students, you might get the brave 3 or 4 interacting with the prof. You know, you might get 10 if you're lucky, but 50 of them are sitting there taking notes. And the last thing you want to do is challenge the professor. But if you're sitting in small groups and they've hit a problem, then you'll have that interaction. So I can't answer that question specifically. And it goes back to, I think, your point. Every culture is different. Every universe is different. So with Lausanne School of Engineering, for example, on that measurements course, they've decided to actually, I think, make that a little bit more concentrated as opposed to kind of separated. They're experimenting with that too. Oh dear. Let's see, where else we go? Oh yeah, actually I was very intrigued by your comments about, you know, the big picture stuff that you were talking about, the schools, your guiding forces. It's very similar. I'm just going to read them out. The school in England, their driving kind of principles are shared future. Everyone has to share the planet, living safely, and living sustainably. It's very, very similar, as opposed to mechanical, electrical, and everything else. By the way, I'm not a big believer in destroying those disciplines completely. I think weaving them in, having people who have stronger preferences for mechanical or electrical or electronic, I think they're fine. That's fine. I mean, in my design teams, they're all a combination. They have a common core of control and robotics that they kind of really, and mechatronics that they all really enjoy. But I have the stronger mechanical guys. They bring something to the table. I have stronger electrical and software guys. So I'm not a big believer in just throwing, again, that's a cultural thing that can be developed by schools. I think I've covered. Have I missed anything of major importance? I really appreciate your comments, by the way. And I think we're a little bit of a unique company. There's not many companies like us around. And there's no question. It's a commercial enterprise. But the idea of actually developing a company that has a heart and soul, or a DNA that's kind of focused on improving engineering education, it's working. We have, I think, 75 people now. And they are genuinely excited. And my engineers, they're young guys, they get to travel. I mean, how many 25-year-olds get to fly to, Algeria or the Middle East or to Brazil, right? I mean, for them, it's great. I'm trying to think if there was one other point that crossed my mind, but I can't remember it right now. No. So I think from what I hear in your comments and from what I've heard from Dr. Cardozo is there's a lot of kind of pent up desire to make change. This is very similar to pretty much everywhere else I go, and I hope that over the course of the next 2 or 3 years, we'd love to participate somehow with yourself or anybody here that's got the energy, the excitement to actually do something different. I think we can help make a difference. I'll share with Dr. Cardozo so he can share it. There's a link to the Mechatronics forum, which is kind of interesting. Now we're getting more and more people to kind of contribute and participate in that. And it's now getting some global traction. Anyway, thanks very much. Hopefully that's good.
So I think the session is up for questions, please. Professor Kaminski.
Paulo Kaminski from the mechanical engineering department from here. My question is more, what we really want is at the end of the course that we have good professionals. This is what all of us wanted. And for this, we think that it's important that the students learn the things that we think that is important to be a good professional. My question is, who learns the things are the students. But one of the central point of this, in my opinion, but this is the question, is which is the central function of the teacher, of the professors. And if you think, or for all of yours, if you think that it's really important, the function of the professor or the teacher, if we could have a new position and could bring a new teacher, what are the abilities, knowledge that we would like for these persons that could bring something better for the students to learn, and that at the end we have a good professional?
I'll make some comments. In a perfect world, we're far from that.
In a really world.
No, I'm really dreaming, right? In a perfect world, I think the ideal professor has the ability to mentor students and guide them, not just impart knowledge. And to do that, certainly to have employable engineers, I would think that most professors should have some sort of commercial background or industrial or experience outside the university environment. The thing that I've noticed is there's a lot of perceptions of the outside world that are wrong, fundamentally wrong, right? Not everyone has them, but it's hard if you haven't spent time outside. That's not going to be possible, right? It doesn't mean to say that people that don't have that aren't valuable. So what in the interim solution, I think, is to encourage people with industrial or commercial or non-university experience to join faculty. So you have that mix, in your common area. So you have joint teaching goals. I got to tell you that from most of the people that I talk to in industry who hire people, very few of them are actually looking for the technical skills when they get to the senior level. When I'm hiring somebody, I'm assuming that my team has identified that they can do their mathematical equations, and they know how to design a control system, and or they can code in these various languages. I'm looking for one thing. I'm looking for personality. I'm looking for their ability to integrate with the company, their work ethic, their professionalism, their desire to achieve our goals, whatever our goals are. And I don't think that that's built in to the typical engineering program, and I think it should be. And people call it soft skills. It's not a soft skill. It's a really hard skill. It's a very challenging skill. So going back to your question, in a perfect world, I think you do want to have mentors in the academic world that are able to distinguish between employable skills and develop the curiosity in students to make sure they don't just walk out of there think they know everything, because the world continues to change, right? So that's a tall order. So I'm not sure if I've helped you, but where I've seen it work the best is where there's a fairly kind of healthy balance or healthy number of industrially or commercially aware people in the faculty. They tend to have a pretty good balance.
Would you like to comment?
I'd like to make
Yeah.
some comments here. Yeah, Kaminska, I think I know maybe what you mean. Because our tradition is that the students learn because we teach, and that's wrong. The students learn because they study, because they are eager to have better and better knowledge. And so I think the main function of a professor nowadays, Kaminski, is to stimulate the students to walk with their own legs. We are not able to teach everything. Sometimes they know better than us some specific topics. So we have to recognize that the world is changing, and we have just to use our experience, you see, because we have a very long experience, and say, don't be afraid, walk with your own legs, face the new problems, you see. And it's impossible to act as in the last 20 or 30 years. So the professor, they have to be humble, much more humble nowadays. The students, they have their own ways, and I think we have just to help them to walk us in the track that they have chosen. So it's not easy because it change again in culture. You see, it's a different.
I just want to comment on that. You touched on a point which I think is actually really, really important. It's the notion of vulnerability. The professor, when I grew up, the old knowledgeable person. I think in the real world today, especially when you got the generation coming through, they respect vulnerability. They actually do, because it's real. Like, nobody can know everything. So the notion of being humble, being a guide, having a two-way conversation as opposed to a one-way conversation. Yeah. And again, I look for those kind of traits in people coming in. And honestly, when I look at the kind of, when you read stories, and I've done a bit of read stories about technical engineering disasters, a lot of them are traced back to one or two very dogmatic people. Yeah. Who aren't willing to be open. Yeah. So,
yeah, and just to comment one of your statements, I think that, and this is a problem in our engineering schools since the 50 years that we start really with research in Brazilian universities. We have forgot good professionals and some important practical discipline. For instance, if you want to design a bridge, you don't learn this by doing in the books. You see, you have to be a good engineer. And then we need the cooperation of the professional engineers in our universities. In general, we are putting these persons aside. You see, they are not academic, but they are very good professionals. We need the cooperation of these people. Now, may I make some joke maybe? For instance, it's people are very much concentrated, and I think it's good on this practical problems. We start the students to take a specific problems and solve these problems, as you mentioned. Then you can propose more difficult challenge and so on and so forth. I ask, and if, but the point is we cannot forget theory, as you mentioned. Theory is important, because otherwise it looks like me as learning how to cook. You learn how to cook potatoes, and then next step is roast beef, and then noodles, and so on. And then your friend got a fever, and your conclusion would be, somebody is trying to cook your brains. No, fever is a thermodynamical problem, but you have to learn and to know the basics, you see, because otherwise you can make some mixing that are not very good. So I think theory is really important. They have to come together with experience. You see, experience is also, I think, is a very new approach, but and it's working quite well. But let's also keep the theory together.
I think we have a very interesting experience here. For instance, I give up working with companies with 100 students in a class. It's impossible. Mm-hmm. So now I'm back because we are changing the curricula. So there is a very lack of teacher there. I'm back to the traditional, more or less. But it's a pity. But we have a very interesting experience here. It's small, but it's very interesting experience. Cardoso is one of the sponsors of that. I am not directly involved, but I'm a kind of orchestrator or sponsor. I don't know how to say it, but in I don't know 5 or 8 years ago, the university launched a kind of I don't know how to say, but it is, you know, the university made a call, to organize or to finance some labs, but not research labs. Because in Brazil there is a fund for research labs. Yeah. There is no funds for educational labs. It's crazy, but it's like that. So the university launched a call for educational labs. We made a kind of improbable arrangement between some guys of production engineering, some guys of electrical engineering, I will say electrical, okay? Sorry. From electrical engineering, some guys of mechatronics, I think it's mechatronics, and 3 different buildings, 3 different departments. So we have a part of the lab in the production engineering, part of the lab there, and part of the lab, I don't know, 300 meters there. Okay. And it works. It's crazy, it works. Associated with, it's a kind of open lab, to say. For instance, there is a business incubator here in the university. Some guys, two lawyers, developed a product. And what do we do with this problem? I was there. Well, let's talk to some companies that your product seems to be correlated to their business. Let's talk to say. They went to a company, a multinational nearby, and they said, okay, but we need a dispenser. It's a kind of glove for teeth to touch. I think it's crazy, but anyway. They were interested, but they would like not the mini glove, but a system, a dispenser. And they went to the lab, because the lab was open. They ended the lab because they could sit there, okay? Only for that. And they were, well, what could I see? The boys there said, well, we can do a dispenser for you. They made the design, they printed it up, and in the afternoon they were back to the company. You know, that works. This is really, really interesting. Really, really interesting. Roseli and Eduardo and Davi and other guys run a course. Roseli is they run a course here. It's a kind of product design course, more or less. And they went to some companies, and the company said, okay, we need to fridge a beer in 20 minutes. So this is one problem. We need to develop, I don't know, monoclonal test to the blood. Okay, this is another problem. So groups from students from depends on who's there, engineering, architectural, economics, physics, and so on. They try to design a product to solve the problem, and it works. It really works. It really works. So, but the problem is that this experience, they are quite small. They are, they are a bit a part of the traditional system. They are not compulsory. You can do if you want, okay? Some guys like it, but we have a lot of hours of courses here. It's a lot of. For instance, the new structure was worse for us. We have to rise because we are below the minimum. So in the last year, we have two hours more classes than we had. Anyway, and this is a problem. But this, I think, this is the experience we could connect to some of the experience you say. The equipment is, but it works. I think I think it's the best experience in the university I saw in the last 10 years. The best experience. We are trying to enlarge it in a new lab that's being created. It's a kind of digital production lab. There will be also guys from machine learning, Fabio Cosmo, I don't know if you know, and the group here from mechatronics. He went in contact with the guys from mathematics in São Carlos here, and they made a group of machine learning. And they knew each other, but they were not working together. And Eduardo set some test beds for machinery, machining, and advanced manufacturing. These guys will work on this with students. I think this could be in next year because it's still not running. A very excitement experience to do what we'll see what's gonna be.
Further question? So maybe the final question I have for all of you. The concept of credit was created in 1893 in Harvard. The credit for discipline. And recently, Harvard killed them. They have no credit in Harvard. So I would like to hear the opinion about the evidence that the discipline are dead. We will have no discipline in all courses, including engineering programs. I would like to hear the opinion of you about this tendency that discipline is dead. Yeah.
I'm going to cheat a little bit because I'm not an educator. So I haven't spent my life educating people. We're supporting the industry, and that's news to me. I didn't know. Is that across?
Yeah, have no credit
Really?
The course is concepts. For example, if you have no the calculus, number 1, you have a integral, double integral, the concept.
But you just take the course. So there's not a. So I'm not sure how that structure works. So I'm
Did you understand?
not really. I'm not sure I fully understand. I mean, does it mean that they take the course, they take the calculus as a concept,
Yes.
but there's
For
no
example,
credit? I
yeah.
don't.
No disciplines. They have a continual. It's only one discipline in all courses.
So how does anyone get evaluated?
For example, limit with the student have a limit with me, integral with you, derivative, but you, no discipline. It's completely independent. Each content.
May I?
Yeah.
I will think loud. I think there are some contents that are suitable for credits for a single discipline. If this content stand alone, we tried to make some integrated approach in between, for instance, disciplines like project development, ergonomics, innovation management, marketing. It didn't work out. Why? Because a student can register in one discipline and not in the other, so it's it cracks the system. Okay, but by the other hand, I don't think if you have no discipline it will work. Maybe we have to think of some groups of disciplines and made together, integrated. We to solve the integration problem. You have to create a discipline with the title integration. It doesn't work. By definition, it doesn't work. So we made an agreement. Okay, what can we do with the discipline? It's a discipline to set up startups. Okay, the guys like it. It works, but it's not an integrated discipline. You know, to see to in one discipline you will utilize all the knowledge you have accumulated in 5 years. It's crazy. Okay, I don't think it works. But I do think it can work if you take some disciplines and made a joint project, a joint educational project, and run together. In that sense, you can end these disciplines, I don't know, do 2 or 3 disciplines, okay, and mix it. I think this could work. But for that, we would have to change the way we work, okay, because in the current way, it's impossible. But the worst, I think the regulation, the federal regulation, CREA, and all these crazy things, is pushing us to disciplines. Now we have to declare in which disciplines, which is the professional ability that a guy that is approved in that discipline would have. It's crazy. You know, for instance, calculus. Okay, which is the professional discipline? I don't know. It's a professional ability when you know, I don't know, the first period of calculus. I really don't know. I think it's none. Okay, it's the base, but we have to declare. Oh, there you get the skills and the thinking to develop further on. It's nothing. Okay, but we are pushed. We are being pushed to specialize and to divide disciplines. This is real.
Well, I agree with you also, Salerno. But I'd like to make some comments on this, Cardoso. This is very important, I think. And I'm back to my first statement. There is no unique solutions. We cannot take Harvard as example for the world, you see. We have different situations, we have different countries, different cultures. If you think of Harvard, I think the acceptance rate in Harvard should be about 5%, I don't know, or 10%, which means that 5 or 10% of the best students in the United States are in Harvard. So their commitment with knowledge is very strong. Okay, so it's a different kind of student. You see, they have a different attitude. I don't think that we could just import the example for Brazilian universities, you see, because we have also a commitment to society. Our universities has to say, we are giving our credit in our diplomas, undergraduate or graduate diploma, to people that are going to serve society, you see, with a good competence. And so I think we have to use some mechanisms that somehow we could, I say, not guarantee 100%, but to say, well, it's high probability that we are putting our students and the society to do a good job. So I think it's we need this kind of evaluation. You mentioned that in some courses maybe it would be possible to use another kind of evaluation, but I think that well, it's my opinion. We need to do this. One thing that we could also use in our academic world and as I would say something that is the aim of the university is saying that once you enter the university, you never leave it. You see, this is open. Let the university open for your students. If I got a degree, I have been talking very much this in the UFABC. If you are a good student and you finish your course, if you want to come 2 years and 3 years ago, come again. Take the course that you need to complement your education, because we don't know what's going to happen tomorrow. Engineering is open. We cannot say, well, you have this undergrad diploma in engineering, then you are prepared for the next 5 years. No, you are not prepared. You are prepared to face new problems.
That's a fundamental tenet of the Lausanne School of Engineering that I mentioned. Yeah. Once you've attended Lausanne, you're welcome back anytime to take any course. I just want to touch on one thing. We talked about Harvard, and we talk to Harvard and MIT and Cambridge in England and Oxford and TU München, the top universities. And you made a really good point. You bring in the top brains, the smartest, brightest, most motivated. They're going to do fine. That doesn't throw them anything. They'll figure it out because they're smart, right? So that's the top 5 small percentile. Part of our goal as a company is to take that big, bunch in the middle and we shift it to the right in terms of knowledge and understanding, reducing the dropout rate, which is why I mentioned that school in San Antonio. It's a tier 2 university in the United States, 250 people, engineers, and unbelievable difference that 1 or 2 professors have made by bringing in this cool technology. What does it do? It just motivates the young students to try harder. They don't get all the math. No, it doesn't really matter. But they're working to get them up to that kind of higher level. So probably some of the better examples of where we've made a difference has been with that bunch in the middle where you've seen a difference. And I was asking Dr. Cardozo this morning. You mentioned the dropout rate is 46% or something in Brazil, but I'm pretty sure it's not 46% at USP, right? You're one of the best universities in the country, right? Sorry, I just wanted to
Okay, it's all right. I'll just do my last comment, Paul. I am a little bit disappointed because you never mentioned Stanford.
think you have no time for your question. I will speak in Portuguese now. Eu agradeço muito a presença de todos para participar desse evento. Foi muito rico para mim, pelo menos, espero que tenha sido rico para todos, né? Esse material está todo disponível. Eu agradeço muito a competência do Instituto de Estudos Avançados, em particular, né, da Sandra e os seus colaboradores aí, pelo profissionalismo, né, na condução do processo, né? E acertei muito bem em pedir auxílio ao Instituto para realizar essa palestra, porque, de fato, foi algo muito bem organizado, né? Coisa que é difícil a gente ter. De qualquer forma, eu agradeço novamente a presença de todos, agradeço aos professores e ao Paul Gilbert, que veio aqui colaborar com suas ideias sobre a educação e engenharia, e esperamos nos ver aí em breve em outro evento similar e torcer para que a nossa engenharia, né, tome caminhos importantes que faça que os nossos estudantes venham para cá para sentir prazer, não sofrer. Essa, eu acho que é o grande desafio que nós temos. Os estudantes de engenharia são os únicos que vão à escola sofrer. Os demais vão para ficar felizes, curtir a vida. Então, quem sabe a gente pode mudar esse cenário. Muito obrigado, então.